Alright, this next video talks about direct and indirect variation. This is found in section 2.3. So direct variation is when y is proportional to x. And that means that if x doubles, then y doubles. If x triples, then y triples. If you take half of x, then y is going to be half. So we set that up as an equation, y equals k times x. So then we say y varies directly as x, and k is that constant of proportionality that we were talking about earlier. So you can also write k is equal to y divided by x. So let's look at a couple of examples with this. Okay. So for example, if it says m varies directly as p, so if you translate what they wrote, m varies directly as p, into what we wrote a minute ago, y varies directly as x, then you have this equation, y equals k times x, can be translated into m equals k times p. So my constant of variation can be found by taking k equals m divided by p. And we end up with a k value of 5. And then I can write my equation, y equals 5 times x, or I can even write m equals 5 times p. So it depends on which way you want to look at it. So a lot of times problems that are done very directly can also be used with proportions, and a lot of times it makes more sense. So if I have this proportion and I say m varies directly as p, m equals 15, p equals 3, find m if p equals 6. So I can set up my proportions, m over p, and then my new m over p. So I have 15 over 3 equals x over 6. And x in this case is going to be m. So then when we cross multiply, we end up with x equals 30. So that means m is equal to 30. Here's another example. If I have 15 over 3 for m and p, and then it says find m if p is 8. Again, if I cross multiply, then I end up with m is equal to 40. So my constant of variation is 5. 15 divided by 3 is 5. So that means that basically I'm taking the denominator and multiplying it by 5 to get the numerator. So that makes sense. So here's another example. I have 15 over 3, but this time I'm looking for p. So I have 12 over p. And when I cross multiply, I end up with p equals 2.4. So again, the value of p is always less. If I were to take 12 and divide it by 5, I would end up with 2.4. So those are all things to think about. So here's the opposite. So we're talking here about something called inverse variation. So a really good example of inverse variation is the length of a field, or the length of an area of a field. That's an example. But here's another one. So it takes a certain amount of time to set up tents at the circus, and it's an inverse variation. The number of elephants used. If 3 elephants are used, it takes 40 hours. And then how long would it take for 12 elephants? So what we have to do is we have to look at this as the proportion, and we're looking at the inverse variation, which is y equals your constant divided by x. So your constant is found by doing y times x. So when we look at this, the amount of elephants used times the number of hours tells us how many total hours have to be done. So for example, if it took 40 hours for each elephant to get this work done, then that means it took 120 total hours. So I need to figure out, if I have more elephants, it's still going to take 120 hours, but each elephant is going to be able to do more work. So I can figure out how much work would be done, how many hours it would take with 12 elephants, which should be less. So 120 divided by 12 means 10 hours. So this is what we refer to as inverse variation. Another example that we have here, this one says it varies inversely as the square of the distance. So for example, my constant is going to be the distance squared. So the astronaut weighs 160 pounds at sea level, and that's about 4,000 miles from the center of from the Earth's center. So find the equation. So 160 times 4 squared is, the constant is 2,560. So my equation should be the constant divided by x, which is constant divided by d squared. So I can use this value, this equation, to find my other things. So what's the distance from the center of the Earth if the astronaut weighs 1 pound? So the weight is the F value, so there's my weight. There's that constant that I found. The d squared is what I'm looking for. So therefore d squared is equal to 2,560. So that means d is equal to 50.9, and I got that by doing the square root of 2,560. So that means that I would only weigh 1 pound when I'm 50.59 thousand miles from the center of the Earth, which is 50,596 miles from the center of the Earth. Here's another one. What's the variation constant? So we already talked about that. That was up above. So we did the 160 times 4 squared, which is 2560. That's our constant of variation. So what's the variation constant if the astronaut weighs 150 pounds? Now we're doing 150 times 4 squared, which would be 2,400. So these are just some examples of inverse variation and direct variation.